If you are a software engineer with 3, 5 or more years of experience and not actively moving towards being AI enabled, you are already falling behind. AI is not coming, AI is already here. And I think AI is not going to replace good engineers, but the engineers who refuse to upgrade how they work. Let's talk about how a normal engineer can become an AI-enabled engineer. First thing, AI coding tools. I don't think it's optional anymore. I think it's becoming a very normal thing and something that everyone's supposed to use. So if you are still not using an AI code helper tool, you should consider using AI tools. And if someone still takes pride in saying that I don't use AI, I don't think that's a discipline anymore. The AI code helpers, the AI tools are getting better and better every single minute. But as engineers, we should understand how these AI tools work. There are certain things that everyone should be very aware of. If I highlight a few things, we should be always aware what data is being retained, whether your code is being used for model training, where your prompts are stored, and what leaves your computer. For personal projects, I don't think this really matters much, but if you are working on company projects that has certain restrictions on privacy and compliance, we should always be cautious on which tools we are using. If it's client work, if it's government work, enterprise or regulated domains, we should always look into these service providers and what are the explicit privacy policies and compliances that these services have. And I always recommend going for paid or business plans so that you get additional controls over what you are sending over to the cloud or to their servers. On the other side, we should also spend some time to do a bit of research on which models are performing better for specific languages and frameworks. There's a lot of feedback from developers who are already using it, and we can make sure that we are using the right models for our day-to-day coding tasks. We should shift towards being the code reviewer instead of the code writer, so that you let the AI tool write the code for you and then you review it and you make sure everything aligns with the code structure, the project structure, the rules, and test the feature works and take it from there. To be an AI-enabled engineer, you do not need to be a machine learning engineer. What you need is AI technical literacy. You must understand hallucinations, non-deterministic outputs, context window limits, token usage, and why different prompts give you different responses and stuff like that. Prompting is not magic. I see prompting like the interface design for this whole thing. And that's mostly how you talk to these AI things. So apart from all this, we should also look into streaming versus blocking responses, tool calls versus free text answers, and why the prompt structures help you get more accurate responses. And I believe if you don't understand where your AI fails, it's really hard to debug an AI application. Now let's go a little bit deeper into different roles like front-end, back-end, and cloud, which areas we should look into studying and practicing to become AI literate. So the important thing with front-end portion with AI applications is not really just a pure API call, it's not really just a fetch. There's a few things that I have learned so far, and the biggest is streaming. Streaming has been there from a long time, but with the models spitting out the text, then the front end needs to handle that streaming and show the response on the UI. So there's multiple ways of doing streaming. I think the most popular ways are server-sent events, SSE, and WebSockets. And related to streaming, we should also spend some time to understand this token by token rendering only the delta difference, and making sure the performance of the front-end application stays as it was. And the next thing is partial failures and retries. Because these API calls are quite long, the model is doing different things and there's certain places that the request can fail. So these errors needs to be handled from the front-end side gracefully. The latency, because if it's a streaming response, there's always latency, always the waiting, the loading period for maybe until our backend agent is executing a tool and then it's waiting for the output. So these things we need to render in the front end with proper skeletons or loading indicators or additional text messages and stuff like that. And I think the UX responsibility has just increased. The AI output is always uncertain. I remember when we were developing applications with Claude Sonnet 3.5 and then we migrated, as in we upgraded the models to use Sonnet 4.0, and then suddenly there's Markdown. The model was sending Markdown to the front end and we were not supporting Markdown before. So I think the UI needs to communicate this uncertainty in a proper handled manner. So in my opinion, the front-end engineers are not going to just handle the state anymore, but they need to handle the uncertainty instead. Coming into backend side, I think backend is the deciding factor if your AI application is going to be powerful or is it going to bring more liabilities. And I think it's where the thing gets more dangerous. So if you are a backend engineer, I think you should start learning on consuming LLMs safely. Nowadays, we see a lot of agentic frameworks. Majority of the agentic frameworks, the underlying concepts are kind of similar. So I believe as a backend engineer, you must look into at least one framework and understand the underlying concepts of how the agents are set up, how they communicate with each other, what are the features that's available, how you handle these streaming responses from the backend. And along with these agentic frameworks, we have MCP tools, MCP servers. Along with this, a very common thing that we always come across is the permission boundaries for different MCP tools or any other tools that certain models are allowed to consume. As an example, if your agent is allowed to do a user password reset, if you allow the model to reset everyone's passwords, that can be abused by some users. We should always be aware of the level of permissions that we are giving these models through our tools. You should also spend some time looking into things like prompt injection, cross-agent data leaks, and determinism strategies like structured outputs or setting the right temperature for different models and agents. Also, another big thing is versioning your prompts. We should treat our prompts like a source code. We should always have different versions and which version is currently published. Otherwise, it gets very messy when we evolve through the project. Along with all this, we should also look into the RAG, Retrieval Augmented Generation patterns. And nowadays, almost all the cloud service providers are providing these RAGs. So it's going to be valuable if you spend some time there as well. If you are a cloud engineer or a DevOps engineer, I want to highlight a few things that you should focus on. The biggest concern, cost. We should be aware of our token burns, our rate limits, if there's any infinite loops running in the agents, and the async execution patterns, stuff like that. And the other very important thing, observability. We really need the visibility into the token usage, which prompts, which LLM calls consumed which number of tokens, and the latency, where is slow, which MCP tool is the slowest, and retry behaviors and failure models, stuff like that. I think consuming LLMs or using AI without the proper observability is really like gambling with money. The logs shouldn't just say that what happened, but it should also say that why it happened. With proper observability setup, we can look into traces and get the exact idea why this has happened. The bugs in AI applications, the AI bugs, doesn't really crash systems. It just drains your wallets. The most important part of the process of being an AI-enabled engineer from a normal engineer, I think, is the mindset shift. Basically, your role has changed. You don't write code anymore. You become the code reviewer, you become the architect, and more importantly, you become the risk owner. AI can code very fast. It can introduce security issues, vulnerabilities, invalid architecture patterns very fast. So we must review the code very aggressively and reject the code that's not aligning with the project architecture or the system design. You are not allowed to say the LLM wrote it. That means you already failed your responsibility as the engineer. My personal opinion, take AI as your junior engineer who never sleeps, writes a lot of things, sounds confident, but lacks a lot of context across domains. Okay, to wrap things up, let me rephrase the whole thing again. AI-enabled engineers will outperform others. Not just because AI types faster, but because they think wider and review better and see system level issues earlier. This shift is already happening, hiring is already adjusting, and promotion decisions already factor this in, even though no one really says it out loud. And I strongly think this isn't the future, this is just the baseline. If you are an engineer in the industry for a while who still haven't gained the AI literacy, start today, right now. It's never gonna go to waste and it helps you make sure that your future is safe. That's about it for the today's session. Catch you guys in the next one.